Good morning, everybody. This is Mark McGinnis. Welcome to this session of the Reynolds Company Tech Talk. Today, we're going to be discussing SIP safety over Ethernet. Now, SIP is a set of protocols that reside in Ethernet IP, and those protocols are the heart of Ethernet IP, and SIP safety is one of the protocols over Ethernet IP. So that's what we're going to be talking today is SIP safety and what makes SIP safety safe. So my name is Mark McGinnis. I'm an automation specialist for the Reynolds Company, and I reside in Fort Worth. I also cover the Austin area. And then we have David Aldrich. David will be talking today, discussing the safety products. David resides in Dallas, actually, but he covers all of DFW and most of Texas as well. We have additional Tech Talks coming up this month. We have these Tech Talks, roughly twice a month or so. On May 26th, we're going to have integration, PowerFlex integration with Fisher Rock. I believe Roger McClary out of West Texas is going to be leading that discussion. We got the Stratix 5800 networks update coming up on Wednesday, June the 9th. Brandon Singh will be leading that. And then on Wednesday, June 23rd, we've got the Rockwell Automation Integrated Services Agreement. And I believe that will be presented by Bradley Freeman. So Tech Talks are about 25, 35-minute discussions, such as today. And they focus mainly on technical issues. And then we have user groups that go into more in-depth discussions. And we have a couple of user groups coming up. One is machine safety versus process safety. And that is coming up on May the 19th. So what we're talking about today, SIP safety, is a machine safety type protocol. But on the user group, they're also going to talk about process safety as well and how those differ from one another. And then a good user group coming up on Wednesday, June the 16th. The middle of next month is going to be system redundancy best practices. That's going to be a very good discussion with the L8 processors. And I advise you to tune into that if you can or are interested in that subject. All of these sessions are recorded and can be viewed at reynoldsonline.com. So SIP safety, what is it and how is it safe? And as I said, SIP safety is safety over Ethernet IP, and it fails to a safe mode, and you define what that safe mode is. So if the network fails, it'll go to safe mode. If the devices fail, the system will go into safe mode. We've got a short video that explains it more concisely than I could ever explain it. And then David is going to talk about the products and technology supporting examples. And so SIP safety and the products that go with SIP safety require a safety processor that would be a GuardLogix or a compact GuardLogix processor to control that safety system. In addition, there is GuardLink. And GuardLink is another way to it's more of a conventional safety. It does not provide safety over Ethernet, but it is a network safety system that came out. I guess it's been out for about 2 or 3 years now, and David Aldrich is going to take you through GuardLink. So GuardLink has advantages on smaller systems, but if you're having a larger system, then we'd probably look at GuardLogix and SIP safety. So SIP safety exists in the standard Ethernet IP architecture. Now, Ethernet IP uses standard off-the-shelf switches. So there are no safety switches. All of the safety resides within the Ethernet IP protocol. And products are offered today with SIP safety built inside of them. And we'll talk about the advantages of the SIP safety. We have in particular VFDs and motion light curtains. To the left there, it looks like there's an access, multi-access control. What that does is let you into safe areas. That connects with SIP safety. So with that, we'll get started with the video.
This video will outline the benefits of using networked functional safety systems and then how fail-safe communications work in modern networks. Just as a refresher, functional safety comprises the active safety measures used to reduce the risk of harm to people, assets, and the environment due to the failure of equipment or improper use. There are lots of applicable standards and resources you can review if you're unfamiliar with functional safety. Functional safety systems are common in discrete industrial applications now. But is your safety system also helping you maximize productivity? Across many industries, increased flexibility requires rapid reconfiguration of machines. Hardwired safety systems employ safety relays, which are interconnected to provide a safety function. Hardwired systems are very effective for simple safety applications. As the system grows to include more inputs and outputs, though, wiring becomes expensive and difficult to troubleshoot, while diagnostics are very limited. If new functionality is needed, these systems require significant rewiring and new validation efforts. If you are using hardwired safety circuits and relays, contemporary safety systems with more intelligence, connectivity, and extensibility could boost your bottom line while keeping your facility safe. Because of these requirements for increased data and connectivity, it is desirable to provide safety services over standard communication networks. One of the leading industrial networks, Ethernet IP, runs on standard unmodified Ethernet. Using the foundation of the Common Industrial Protocol, an open communications specification managed by ODVA. Because SIP exists only in the application layer of the OSI and TCP models, it is easy to add high-integrity safety services and diagnostics without requiring special communications hardware. This leverages existing communication infrastructure and helps reduce lifecycle costs. This enhanced protocol is called SIP Safety, and it can coexist with other application layer protocols like SIP Motion and SIP Security. Safety data in the device is packed into the SIP Safety protocol, which resides inside an Ethernet IP packet, which becomes an Ethernet frame. Since making a safety-rated network would be impractical, the SIP Safety protocol leverages the black channel principle, putting the intelligence in the end devices instead of the network hardware. That means maximum flexibility of network design is possible without compromising safety. The end devices perform the diagnostics on the SIP Safety protocol to detect each type of error that could occur in the network, so that the device can still go to a safe state when an error occurs. Let's look at how those errors are mitigated. To measure the age of the data, which can detect packets which are lost, delayed, repeated, inserted, or out of sequence, a combination of timestamps and time expectation is used. The device compares received data against an expected age limit for packets. To keep the clock synchronized, time coordination messages are passed as well. It is important to prevent unauthorized devices from being part of the safe logical connection, so the CRCs in each message are initialized with unique identifiers from the devices. There is a 16-bit CRC appended to the data, plus an inverted version of the original data and a 24-bit CRC of the inverted data and timestamp, split into two parts. This prevents accidental corruption of bits from being undetected. The previously mentioned methods are only used by safety devices to prevent standard data as being interpreted as safety data. All of these together, plus additional measures for configuration, allows a single Ethernet cable to deliver fault-tolerant functional safety. SIP Safety has been verified and certified by TÜV Rheinland to be SIL 3 Category 4 Performance Level E and recorded in the internationally recognized standard IEC 61784-3-2. Using SIP Safety as part of your system can maintain or improve your safety while increasing the effectiveness of your organization. For more information about SIP Safety, visit odva.org or contact one of the many licensed vendors with SIP Safety products.
So that video showed us that there are several ways that the protocol is determined safe. Well, also it's certified by TÜV as well. But you know, it's got time stamping and data inversion, CRC checking. So SIP Safety is widely becoming accepted now. One of its main benefits is reduced system cost and reduction in the wiring of the safety circuit. So in wired safety circuits, if you have a large machine and you wire it, then your safety system is what it is. It may interfere with production, but production will work around the safety of the system, and that may decrease production. So with Ethernet, with SIP Safety, we get better diagnostics and more information, more status. These devices, the drives, the VFDs, the motion drives, as well as light curtains, they all produce diagnostic data, and the data is useful in determining the reliability of the system. As also increased flexibility is another advantage of SIP Safety. If you don't like the safety strategy, if it's not fitting your operation, then you can simply reprogram that strategy. You don't have to rewire that strategy. Now, on smaller pieces of equipment, you may want to continue with wired safety, but in larger pieces of equipment, you might consider going to safety over Ethernet IP. So it will, the idea is to maximize productivity and uptime, and so make the equipment not only safe, but also productive. Studio 5000 has the instructions. These instructions are used with the safety controller. Here we're showing a dual channel stop instruction on this piece of ladder logic. There are other instructions. There are some advanced motion safety instructions, safe speed instruction. So there's a variety of instructions within Studio 5000 for safety. Reduced troubleshooting time and enhanced diagnostics. We can see what's going on with the safety, and we can trap on any errors that may be going on in the safety system, and decreased validation time. So those are the advantages of working with SIP Safety, safety over Ethernet. And with that, I will turn it over to David Aldrich.
Hey, thanks, Mark. So, Mark's been going over the the protocol and what makes it safe. And really, within a safety function system, there's three components. You have a safety input device, a safety logic device, and then a safety output device. So within the SIP safety world, Rockwell has become one of the leaders in putting these products out. First to the market with several of these products, but kind of wanted to give you an idea of what those products are and where they might fit into your safety circuit. So with the first group, we'll look at the input devices that are available currently that have the SIP safety built into it. And the first one is the Bolton 442G multifunction access box. These are used in robot sales or guard locking applications where there's a hazard that personnel have to get into. And usually that's done with a guard lock and switch. There's an e-stop button there. There's another station there to request entry into that zone. And anyway, that's usually pretty convoluted with a lot of wiring that has to go back to regular safety monitor relays or even compact guard logics to the safety I/O. But with the 442G multifunction access box with the SIP safety over Ethernet, you're simply supplying power and then the Ethernet connection to that. And like Mark was mentioning earlier, all the design and diagnostics and all that stuff is pulled up through the add-on profiles and the instructions in Studio 5000. So makes for a very clean installation, as well as ease of installation and troubleshooting when there's a lot fewer wires that you have to run down and understand what kind of issues you may be running into. The next input device is the 450L safety light curtains. Rockwell's the first one to introduce a light curtain on Ethernet. This is done with our standard 450L light curtains, either the basic or the enhanced light curtains, and then you simply connect those to the 450L EN ETR module, and that brings that back over SIP safety over Ethernet. So you're using standard patch cords from the light curtains to the module, and then standard Ethernet connections back to the processor or to the network. The soon to be released should be anytime this month actually, is the new 442L Safe Zone 3 laser scanner. This will be the first laser scanner as well on the market that has SIP safety built into it. And it's configurable up to 8 zones, has about a 5-meter sensing range in a very small package. So again, the whole idea is to have flexibility as well when you're setting up your system. So all this, being able to configure 8 different zones via Ethernet and through an add-on profile in one program versus having multiple programs for somebody else's safety scanner connected to your safety network, really decreases the startup time and troubleshooting time for your systems. And then we also have the 843 ES. It's a SIP safety over Ethernet encoder. You'll use these with our integrated drive and servo motors for speed control applications. All right, so then we're going to move on to what does it look like on the logic side. Hopefully most of you are familiar with these, but we have both the GuardLogix 5570 and 5580 controllers for the logic side, as well as the compact GuardLogix 5370 and the 5380 that we can be used. So like Mark was mentioning earlier, SIP safety over Ethernet requires the use of a safety controller, because everything's going to be on a network and will be brought back into the controller. And shows up in the I/O tree as a piece of hardware, a piece of I/O in the I/O tree, and also you'll use that with the safety I/O that's associated with it as well. If you're not using the SIP safety products as well, so you can bring the rest of the hardwired products back over into the controller, the safety controller task. And then finally, we have the SIP safety over Ethernet output devices. Currently, the PowerFlex 527 AC drives, they have safe torque off built into them. Again, integrated motion is pretty key. And then the PowerFlex 755 family as well has a network safe torque off control module now that you can use as well to communicate via SIP safety over Ethernet. And the same holds true for the Connect 5500 and 5700 servo drives. And then if you're into on machine, we do have the ArmorStart STs that have built-in SIP safety over Ethernet as well. So that's a look at the current products that are out there for SIP safety over Ethernet. And I thought we'd show a couple, examples of why and where you'd want to use SIP safety over Ethernet. Really, a lot of things with the drives and motion are becoming increasingly integrated within Rockwell, especially within Studio 5000, and be able to do all your controls and everything within one program. So the top picture there shows a traditional integrated system with standard, safety interlocks, safety push buttons, enabling switch, encoders. All those items are hardwired back to either safety monitoring relays or to the safety controller I/O. So there's a lot of wiring that's being done. If you have to make a change, you got to go out and do the hard wiring there. So looking at the contemporary or the newer way of doing things with SIP safety over Ethernet, now you're simply connecting these devices to the network switch and bringing it back to the controller and performing all those tasks within the program itself. So it really reduces up to 40 or 45 40 to 50% of your wiring in the field, which obviously increases your speed of commissioning of those systems. And then as well, reducing the startup time for those machines as well. Here's another look again, showing the 5380, connected to the 442G multifunction access box, using the SIP safety encoder, communicating over SIP safety over Ethernet back to a PowerFlex 755 with that integrated safe torque off card in there. So what does this all look like from the plant floor up? So really what this does is it gives you much better diagnostics, much more, quicker information, more information status on your safety devices. So you kind of go from the plant floor up into your connected enterprise. So on the right-hand side, you can see where we have the safety over Ethernet devices. So the light curtains, the laser scanner, the encoder, those are easily connected to your plant-wide system. And then over on the left-hand side is all the other devices that don't have Ethernet built into them, but we do have a way of getting that information, at least the diagnostics and the status, back up to the connected enterprise through GuardLink, and we'll talk about that here in a minute. But the reason for GuardLink is if you think about an e-stop or a interlock switch, it's kind of expensive, or the devices are actually just too small to put an Ethernet connection onto those devices. So it's a way to take a traditionally discrete product and then be able to pull diagnostics and safety information from those products over Ethernet back into your controller, back into your HMI, and into your information software for your facility. So GuardLink is, again, this is what's used. It's a safety system, safety network that is used to provide safety diagnostics. You can also do remote reset, lock and unlock commands over a standard cable. It's TUV certified. It's kind of a trunk and it's a trunk and drop topology, and it consists of a GuardMaster DG safety relay. That's dual GuardLink safety relay. So you can actually put two GuardLink systems onto one safety relay. And each safety GuardLink system can handle up to 32 devices. And again, it's a standard trunk and drop. The wiring is just for the trunk is a 4-wire connection, and then from the device to the tap is actually just a 5 or 8 wire, depending on what the device is. And the devices can be typically any electromechanical device like an e-stop, an interlock switch, or it can be a solid state device such as a light curtain, a laser scanner, and things like that. You can go up to 1,000 meters, 30 meters between taps, and then 10 meters from tap to the device. And then what brings us back into the connected enterprise is there's an Ethernet IP interface module that connects or sits next to the GuardLink safety relay. And it talks optically, and that allows that information that's coming from the DG safety relay to be pulled back into the controller and the HMI. And again, that provides the diagnostics. You can then, request lock or unlock for your guard locking applications over the network. You can do resets and things like that over the Ethernet network back to the GuardLink safety monitoring relay. And of course, there's an add-on profile for this in Studio 5000. So all these devices that are out there on GuardLink, you can easily pull that information in through the add-on profile. The add-on profile allows you to actually connect to that DG and then actually go out and upload and see what's out on that GuardLink network. You don't have to add each one individually to the program. It will actually go out there and scan it for you, again, to increase that speed to commissioning. So that's a quick overview on what you would do with any products that don't have that SIP safety over Ethernet. I guess the other thing I should point out here is GuardLink is meant for series connected devices. So typically you'll have a packaging machine or machines that have a bunch of e-stops or interlocks and things like that that are all wired in series. GuardLink again, the nice thing about GuardLink is you're using standard patch cords, cables. Reduces that wiring time out in the field. Typically with an e-stop or anything out there, you're usually traditionally wiring an e-stop, safety circuits back to a safety relay, and then you also run an auxiliary contact off of those devices back to the PLC, so you can tell which one of those series connected devices are activated or faulted or anything like that. So with GuardLink now, all that information is pulled back through the GuardLink protocol, and then you can pick up that information through the add-on profile in the Ethernet module and not have to wire back that auxiliary back into the PLC just to pick up that status. So I know that's a lot of information, but there are lots of Rockwell Automation safety resources out there. Just to name a few, there's a Machinery SafeBook 5 out there that helps with, making sure you're building your safety circuits the way you need to. The GuardLogix Safety Systems Reference Manual. Again, that'll work with the GuardLogix and Compact GuardLogix, talking about the safety tasks and how that works. There's also a link to the video that we had shown earlier. And Rockwell also has over 75 pre-engineered safety functions, and that does include ones with the Compact GuardLogix or GuardLogix in it, which will provide you a safety function showing the safety inputs, the logic device, the output device, provide you with sample code and things like that to help speed up your safety network, or I'm sorry, your safety design and commissioning. And then also Rockwell has a nice white paper also that talks about SIP safety over network, and talks about the SIP safety protocol and how it's safe and all those things. So I believe that is all we have for today. If there are any questions, please let us know, and we'd be more than happy to answer. We look forward to seeing you or on our next Tech Talks or in upcoming user group meetings.
Thank you, David.